Okay, now I'd like to go ahead and wire up our monthly sales by product line chart. So this chart will still have 3 data series, and we'll use our web API as we've done in other parts of this application so far to populate the data here. So we'll head back into the application, and what I'm going to do is make a commit. And we'll say add themes, pie chart functionality. Okay, so I think I like the bright theme here a little bit better, so we'll save that in our pie chart, and we will close some of the other tabs that we have open. Let's head back into our section sales component. This is the parent component template of where we've defined our line chart. And I'm going to, once again here, we'll just have a specific line chart that we'd like to display. In this case, rather than pass it input data, we're going to have the line chart component for now handle the data that it would like to receive specifically. Once again, if you'd like to make this a little bit more flexible, then feel free to refactor what we write here to provide inputs from the parent component if that's something that you'd like to set up. So we'll just keep our app line chart component as it is defined in the parent component, and we'll head into the line chart component template. Now what I'm going to do here is, as we've done before in our other charts, is define an ng if here, and we'll say if chart data. So if we get chart data back, we'll begin to draw the canvas, otherwise we won't. And what this will do is prevent any errors that we might receive if the canvas element begins getting created before we get chart data returned. So now we'll head into the line chart component, and just as we've done previously, I'm going to comment out some of the sample data. Okay, so what I'm going to do here is I'm going to specify 2 new properties that we'll use to store some data while we're kind of wrangling the data from our API ultimately into the properties that we'll use to set up our line chart. I'm going to create a top customers string, actually string array. Sorry, and this should be top customers. And then I'm going to create an all orders array, which we'll just say can be an array of anything. And so we're going to rely on our sales data service, as we've done in the past, to pull orders back from our database. So once again, we'll do that in the ng on init method here. So we'll say this sales data service dot get orders, and once again we'll get a single page of 100 orders. And as we've done in the past, we'll also subscribe to this and then do something when the result is returned. So if we think about what we'd like to display on our line chart, what I think I'd like to do is to get the top 3 customers by sales volume, and then let's map, and then let's create a series for each of those customers that maps their orders by day over some date range. And let's assume that that date range will be the full set of dates that gets returned from get orders, the unique set of dates that comes back from that. So we'll get the top 100 orders, which will return the 100 most recent orders. And then we'll take our top customers, which we can get back from our API, from a specific API call. We'll get the top 3 customers, and then we'll plot their orders over time. So this is going to end up being a fairly complex operation considering the API calls that we have to work with. So first of all, let's go ahead and just console.log the result we get back from our sales data service when we call get orders, just to refamiliarize ourselves with that. So we can say get orders, and we'll go ahead and console log this and take a look. So get orders returns this object that has a page object and then this total pages for the number of pages that are in the set. We won't worry about that, but we'll go into page, And then page has an object data as well as this total for the 1,000 orders that are in our system. But this data object is where we have all the data that we kind of need to wrangle. So we've got an array of 100 order objects. So these have the customer on them, and they also have the order total, so the amount that was paid for the order, and then we have this familiar date time stamp for when the order was placed. And for the 100 most recent orders, most of these completed is null, but then some of them are completed. In any case, the data that we need to worry about will pertain to the total amount paid for a particular order, the date, and then the customer who placed the order. But we only want to grab orders that correspond to one of our top 3 customers. So let's go ahead and make an API call to get our top customers. So we'll go ahead and remove the console log, and in fact we'll replace that by setting our all orders property equal to the response, and then we'll just go directly to the data, which is nested in this page object. Okay, and just in case you'd like to see this as well, this is just the page object that we were just looking at. And so here it is. So this is just our array of orders. So to get our top customers, what we can do is we can make use of the API call getOrdersByCustomer. So let's go ahead and do that within our subscription here. So we can say this sales data service getOrdersByCustomer. And now we provide as an argument the number of customers that we would like to retrieve back from our database. This is already sorted by sales volume at the API level. And we'll go ahead and subscribe to this. And just for the sake of making it different, we'll make the lambda different. And now what we'll do is we'll set this top customers string array to the response that we get back. We'll use the map function to specifically get back the customer name. So the API call to get orders by customer, passing it the top 3 customers. So if we hit F12 here, we can see that we're hitting this route. And so we pass it 3. This will return us the 3 customers with the highest sales volume. That's ordered by descending. So once we have that, we'll go ahead and grab the customer name from that response, and we map it to a new string array, in this case, our this.topCustomers property. So we have our 3 top customers. And I should note that we have the 3 top customers in the context of the get orders call to our database, which is returning all the top 100, all of the 100 most recent orders from our database. So what I'm going to do is create a constant, and we're going to call this all chart data. And what we're going to do is take our top customers, which again is just this string array, and we're going to reduce over it. So we're going to be using reduce a lot, perhaps even more so than when we were building our bar chart. But the reasons why will be the same. So we're essentially trying to iterate over some array with some function so that we can then build out new data, new arrays to work with. So we're going to reduce over top customers. Let's go ahead and build our callback function. The first parameter, if you recall, will be the accumulator, and the second parameter will be our current value. And so we're going to write a function. And what we're going to do is push onto our accumulator some data. And we're going to get that data in a separate function to keep this kind of a little more organized. And what we'll push onto that accumulator is going to be the responsibility of a separate function here, just to kind of keep things hopefully a little bit more neat. This class is already going to be a little crowded. Okay, and then the initial value of our accumulator is just an array, an empty array. And ultimately when that occurs, once we get the chart data, sorry, this should be get chart data, we're going to return the result. So now let's write get chart data. So I'm going to write this separate from, so I'm going to write this down here beneath our ng-on-init method. And so we can see that we wrote this to take the initial response we're actually getting back from our get orders call. So that res here corresponds to the res from our subscribe here. So that's the result that we get back from our call to get orders. So in fact, we could even make this all orders. And we also pass it I, which is the current iteration of customer in our top customers array. So what we'll do is, we'll call the first argument that we pass get chart data all orders, and we'll just say for now that it can be anything. And we'll pass name, which is the customer name, which is definitely a string. So all orders is coming in as the collection of order objects. So let's get the orders that correspond to this particular customer, and we can use the filter function for that. So let's go ahead and say customer orders is simply equal to all orders dot filter, and we'll filter on customer dot name where it's equal to the name that we pass our function. So if we're just to console.log this for right now, and I'll label it just so it's easier to find, and we take a look at that on our page. So of course it's getting called 3 times here because we are calling get chart data within our reduce over the top customers string array, which has 3 customers in it. So we can actually see the orders for each of those customers. So all of the orders in this first set will be for XYZ foods. So we can see that. All of the orders in the second call will be from this Peak Co. And all of the orders in the third set will be from this Quick Bakery company. So we can see that here. So it looks like out of the 100 orders that we have for our 3 top customers, they had 7 orders, 9, and 8 orders respectively. Okay, so that's cool. In fact, if we wanted to see that these were specifically for those customers, what we could do is log the name, and we'll just put the name out to the console, and then we could do the customer orders for that particular customer out to the console as well. So we can take a look at that. This makes it a little bit more clear. So now we can see XYZ has this array of orders, Pico has this array, and Quick Bakery has this array. Okay, so far so good. So let's go ahead and format this into a slightly different form that we can use. After all, we're just after the order total and the customer name. So I'm going to create a constant formatted orders, and we're going to reduce over this customer orders array that we were just looking at for each customer. So let's go ahead and reduce. We'll have our accumulator and our iterator in the callback function, and then onto the accumulator we'll go ahead and push, and we'll push an array that has the current iterations order placed as well as the current iterations order total. And then of course we'll return R so that we can build it over time, and the initial value for our reduce function will be an array. And now if we console.log formatted orders, we can see what this looks like. So here's our formatted orders. So for each of our customers, we now have an array with this sort of timestamp as well as the total for that particular timestamp. Okay, so far so good. Our ultimate goal is to get this in a sort of object structure that looks something like the sample data that we had, where we have a data array that has an array of order totals here, and then a label for the customer name, and then the sort of tricky part here will be to have our chart labels correspond to a unique day, and have that line up one-to-one with each of the elements that is in the data array for each of the customers. The reason why that's tricky is that our API, if you recall, is simply returning order data. So we'll have multiple days, for instance, where something was ordered more than once on a particular day. And we'll also have instances where, say, the second customer might have certain days where they didn't order anything at all, or the third customer, etc. And so what we need to do is to display 0 for the order total for that day if the customer didn't order anything on that day. And so what we need to do is to get a set of labels that correspond to all of the dates, the distinct dates from our order set, and sum the total of the orders for each day, and of course have 0 if nothing was ordered on a particular day for a customer. So that's sort of what we're slowly working our way towards here. Okay, now that we have our formatted orders, what I'd like to do is to go ahead and return an object here. And we're going to return an object with a customer, and in this case we'll just return back the name, and the data will return back our formatted orders. And so if you're interested in seeing that, I'll comment out console.log that we just did, and we'll make this a constant result, and we can take a look at that. So pretty straightforward. We're returning a result each time over our customer array. And so for XYZ Foods, we have an object that has a customer property and then data, which contains all the orders for this customer with the timestamp and then the amount paid for each of the 3 customers. So that's pretty straightforward. Now, rather than just logging it, let's go ahead and just return it. So yeah, you could return it directly, or as I've done here, store it as a constant and return it, just so that we could console.log when necessary for debugging purposes. Okay, if we scroll back up to where we invoked getChartData, we go ahead and fix a typo here. That should be all chart data. So we're reducing over our top customers array, and we're able to then build out this result, which is pushing the return from getChartData into this result array here. So that's all good, but we still have that issue of determining what dates exist for each customer and what dates they don't have orders for, and duplicates, that sort of thing. So let's just take care of that with a variable so we can that will update. So we'll say let, so let dates is equal to all chart data, and what we're going to do is map each of the elements data specifically, and then we're going to reduce over that, which for each of these elements is of course going to be the set of orders for that customer. So we'll have our accumulator and our iterator. And what we'll do here is push onto our accumulator the date from each of those orders. And so that's the current iterator. And then we need to grab the date from each of them. So we'll map here. And we'll go ahead and map the first element of that array, which is the date. And if we want this to be an actual JavaScript date, then we can wrap it in new date. Okay, and then of course we got to return the accumulator, and we should specify the initial object here as an array that we're pushing onto. Now it's going to yell at us that dates doesn't change here. It's never reassigned, and so to use constant, we're going to reassign it in just a moment. Let's console.log dates and take a look at what it looks like. So here's our dates. We have an array of 3 arrays, and what we have in each of them are the dates for each of the orders for our customers. So you can see that in some cases an order was placed twice in one day or more. So like November 2nd here occurs twice for the first customer, and we see some other duplicates here. The other thing that we see is that there are dates missing if a customer didn't order on a particular day. So we can see here we have October 28th, 29th, but are missing the 30th and the 31st because the first customer didn't place any orders on those days. So what I would like to do is ultimately get all of the unique days, disregarding the rest of the timestamp here, just get all of the unique days from this set of 3 arrays. So that's actually not too difficult. Go ahead and comment out our console log. We're going to reassign dates, and we're going to use this syntax. So empty array and then concat.apply, and then the first argument we can just say is an empty array and apply, but then dates. So now if we console log dates, we can see that all we've done is we've kind of concatenated each of the dates in those 3 arrays into a brand new array, starting with an empty array. So we reassigned dates to an empty array and concatenated all 3 arrays that we got when we reduced over our chart data. So let's go take a look at that. So now we have one big flat array. So that's the first step. The next step is now to get the unique values here and also to disregard all of this extra information apart from the specific day. So the way that we're going to do that is in a separate function here. Let's go ahead and just comment out dates again, comment out console.logging dates, I should say. And we're going to store everything in a constant here, which will essentially represent our customer orders by a particular date. And so the way that this is going to work is, let's go ahead and just make our constant R, and we'll write a function for this. We'll say get customer orders by date. I would name R something like customer orders by date, but it would take up a lot of space, and it's obvious from the name of the function what R is here. So get customer orders by date, and we're going to pass it all chart data and our set of dates. So let's go ahead and write this method. We'll go beneath get chart data and we'll write get customer orders by dates. And we'll pass it orders, which for now we'll just say is anything, and dates, which we'll also say is anything, just to get going here. So the goal of this function is really to provide us with a data structure that looks something like this. So I'm going to write it in comments here just to keep us more or less focused on the output of this function. What we want to do is more or less for each customer and then for each date that we have in our array, produce a data structure that looks something like this. We'll have an object that will have a data property on it that will basically contain an array of objects to represent our 3 customers and their orders. So we'll just fill out one of these. These sub-objects will basically have this structure where we have some customer name and some orders property, which is an array of orders, each of which have a date and a total. So like, let's say the date, and this will be a human readable date or just a short date where we have like 17, whatever the date is, and then the total, which in some cases is 0, in some cases is some number, etc. So it's a relatively complex data structure, but we should have no problem building it, especially if we just go slowly here and kind of talk through it. I'll also leave this component more or less open for refactoring, so if you refactor to make it a bit simpler, then let me know. But I think it is good exercise, more or less going through a component like this, working with an API that provides you with some data that you may or may not be able to necessarily control at the server level, and then just get some practice using JavaScript functions, particularly map, filter, and reduce to kind of wrangle that data into some data structure that can then be consumed by something like chart.js. So I think it's a good skill to have and probably representative of something that you'd see in the real world. So I know it's definitely like that for me sometimes at work when I don't necessarily have control over the entire code base, and I'm getting data back from some service that has a data structure that I don't have much control over, and yet I need to restructure it so that I can use it in a library like this. And so yeah, I think it's a good exercise. So we'll continue through with it. What I'm going to do is, first of all, we know we'll need our customers, and now we're just getting our formatted orders and our dates. So to make things simple, at first anyway, we'll have just our customers, which we'll set to this .top customers. And then our dates, let's go ahead and call them pretty dates, and we'll basically make them into a more friendly format for our chart. So what we'll do is map all of the dates, and we can do that with a function, with a custom method here. We'll just call it toFriendlyDate. And we'll pass each element of the dates array to that method. So we'll write it here, toFriendlyDate will take a date, which of course is always going to be of type date. And we're going to use moment to transform it. And we'll just grab the and we'll just grab the end of the day, say, we could use the end or the beginning of the day, and we'll format it into something that we'd like to see on our chart eventually. So we'll do year, month, day like this. Okay, and I'll fix the typo here. This is of course dates. And if we console log pretty dates, we're still gonna have dupes. So let's just do that so we can see. So here's our pretty dates array where they're formatted nicely, but we have dupes because of the fact that we're just iterating over each set in our dates, which contain multiple orders. And so let's think about how we can get a unique set of dates from this collection. For that, we'll use a little bit more simple JavaScript for that. We'll create a constant u, which will be representative of our unique dates. And then we can do something like this. We can say array from, and then we can get the set of all these dates. We do that just by creating a new set and passing it our pretty dates. And if we like, we can go ahead and sort that too so that they're all in order. Okay, so this is actually going to get us the unique set of dates from this array. So that's pretty cool. And in fact, if we log that array out to the console, we can see that now as well. So there's our set of unique dates sorted in chronological order, actually technically sorted in alphanumeric order here, but because the way that we've structured it here, it's also chronological. Okay, so enough with the setup in this function. Let's go ahead and start building out the structure that we'd like to return. I'm going to continue making comments here so that hopefully it's easier to follow. We're going to define our result object to return. And we'll start out just defining that as an empty object. And then we kind of looked at the structure here for the way we'd like that object to look. And so let's call this property data, and we'll define it as our data sets. So we'll say data sets is equal to result at the key data, and that's just going to start out as an empty array. So if we console.log result out, we can see that we will have the structure for our results started. So it's just this object, and then, sorry, this should be called data and not date. So there's our object. It currently just has an empty data array in it. So this is where things are going to get a little more complex, and then it will be the end of the complexity, more or less, for this entire component. So one more kind of deep dive here, writing some functions out. If you think about it, what we want to do is really iterate over each of the customers and build out their orders. So a good place to start there would be to simply reduce over the customers. We know that we're going to be writing some function over each of the elements in our customers array. You can sort of think of it as saying like for each of our customers. And we're going to write our callback function a little bit differently, in that we'll have one additional parameter here. So if you supply a third parameter to reduce, this is actually the index of the current iteration. So just to recap, again, x in this case will be our accumulator, y is the current iteration, and I is the index of that iteration. And so reduce is really nice in that we have both the value of the current iteration as well as the index. So this would be analogous to, say, when we were writing if we were writing like a for loop and we said for I equals 0, I less than some number I plus plus, then I is our index. So we have access to that as the third parameter in our callback function when we're using reduce. So we're going to make the initial object an empty array, and ultimately we're going to return the accumulator back as well. If you'd like to see I iterate, we can just console.log that here as well. I'm console logging a lot, but I hope that this helps you if you haven't done much JavaScript, or if you haven't used filter reduce, mat filter reduce much. Sometimes it helps just console.log to get the practice seeing exactly what's happening. So we can see I here. And you can see it just starts out at 0 and then goes to 1 and then 2. That's the index. So what we're going to do is for each element in our data sets, and we can access that again with the index, so that'll be the keys. We're going to build out our datasets object. So our customer will simply be y. So that's the current iteration, and we're iterating over this array of strings customer, and that's the customer name. So we can just set that customer that we're trying to build here to y because that's the customer name. Now, we need to build out this array of orders objects. So let's go ahead and do that. Orders is going to be equal to what? Well, we need to get the orders for each date in the set of possible dates that we have. So what we can do is reduce over our unique set of pretty dates in this case. So I'll put this out in a separate line. So we're going to reduce, and I'm going to give it a callback function that will also contain an accumulator, an iterator, and an index. And now we just need to build out this array of orders. So it helps here to just stop, and anytime we're inside of a function, just think about specifically what that function is doing. So right now we are just concerned with building out this orders array. And quite simply, each of these order objects in our orders array will have a property date with the friendly date format and an order total, which will be the sum for all of the orders for that particular date for a customer. So if we just think about how simple that particular operation is, then it helps, from getting too confused about the fact that we are now reducing inside of a reducer that's doing something at a slightly higher level. So each of our orders will be an object. So let's just create a constant object. We'll make it an empty object. And we'll set that object's date to the current iteration, which again, we're reducing over our friendly dates or pretty dates. And we'll set the object's date equal to the date, again, because we're reducing over our pretty dates. And then the object's total, we'll just write this in a separate function again to keep things kind of neat. We'll just get the customer date total for that date for the particular customer. And just so it's clear, we want to sum total orders for this customer on this day. And so let's go ahead and write that function here. Get customer date total. And it's going to take a date, which in this case is coming in as a string, and it'll take a customer also coming in as a string. So let's assume that this gets us what we need, and we'll write it out in a minute, but while our thoughts are still on completing this reduce function, let's go ahead and finish it out. So what we need to do is we've created this object and we've set its date and its total, and we obviously need to push it into some array here because again, we're going for each customer, we want to get the array of their orders. So what I'll do is right here, just above where we begin iterating over the orders for the particular customer, create a constant customer orders array, and we'll just make this empty. And what we can do is customer orders dot push, and we'll push this object onto it, and then we can go ahead and return it. And it's going to be upset that this is an object as far as it's concerned and not a type string. So for our date here, we'll go ahead and just say that this can be anything. Okay, so let's go ahead and put a console.log in here so we can see exactly what's happening sort of at each step. So just below where we begin reducing over our customers array, that's console.log, a message that will say reducing, and then we'll provide the iterator, which will be the name of our customer, and we can say at index I. Okay, so let's go take a look at the page. And so there we go, we're reducing XYZ foods, it's the index 0, Pico is the next, and Quick Bakery is the next. And then we begin reducing over the dates. These are just the pretty dates, or the the to-friendly dates, the distinct array of them. So I'm just going to copy our console.log here and paste it in the second reduce. And here we're reducing that day at some particular index. So let's go take a look at this. So you can see that for XYZ foods, we reduce at each date in our array. And so you can see that happened, and then we go back to the first reduce and we reduce over the company at each day. Likewise for the third company here, and you can see the index increase. Likewise, if you would like to see the total customer orders getting built, now we need to simply provide the functionality of getting the customer date total for the particular day for the particular customer. So let's go ahead and complete our customer date total method here. This one's going to be relatively straightforward. I'm just going to have a constant R, and we'll grab all the orders and we'll filter by the customer name. Where it's equal to the customer that we pass this method, and the date that the order was placed is equal to the date that we passed this method. And so we can just go ahead and grab that by using our friendly date method that we've already built, and take the order placed date and look for it where it matches the date that we passed this method. I'm going to go ahead and put this out on the second line so it's easier to read. Okay, so if we find a match, when we filter, we'll store that as R. And now what we need to do is to handle the case where we have multiple orders on the same day and we sum their order totals. And so we'll store that in a constant result. And what we're going to build here is essentially that archetypal example of reduce, which is just sort of a summation function for an array, where we simply return the accumulator plus the total on each of our orders, starting with 0. So what happens here when there is nothing in R? Well, we'll just get 0, which is good because now we're going to have a value for every date in each customer's orders array. Even if the customer didn't order anything on that date, we'll get a value of 0. So in this way, we have built out this nice structure where we have the same dates in every customer's orders array, and therefore we can plot them on the same axis as each of the other customers in the set. Okay, so that is just about it in terms of setting up the customer data. And just if you'd like to see actually what's happening here, we'll move the console.log just before the return. And what we can do is say, check out the customer orders, and we can watch this kind of grow over time as we iterate in our reduce. So we can take a look at this on the page. And yeah, so you can see it grow for each customer. And we just continue adding until we have orders at each date. So if we take a look at one, yeah, well, we see the dates here. It looks like our total is undefined. So let's go ahead and fix that very quickly. So we're calling get customer date total. Let's make sure, first of all, Let's make sure that we have a value for all orders. And indeed we do. All orders is populated. So we'll make sure that we're getting a value for R here. So we can console.log R. And indeed it looks like we're getting values for R when there is an order. And now I see the error. So we're not actually returning anything yet from get customer date total, which will be important. So let's go ahead and return a result that we worked relatively hard at building. So we'll go ahead and make sure that we return the result. And now we'll come back and check out this console.log that gets called inside of our nested reduce. And yeah, so we can see that that array of customer orders is getting built out for each of the 8 dates. And we have this nice object structure where the order has this form of date and total. And on days that there are no orders, we have 0. And we only have a unique set of days, so that days that have multiple orders get the orders summed. All right, so that is a lot of data restructuring just to get it in a format that we can use relatively flexibly in chart.js. So the last step is to actually push it into our line chart data and our line chart labels. So we'll scroll up into our onInit method. R is this nice data structure that we get back. We'll check it out. This will be the last console.log that we do. And I'll scroll down here and remove the other console.logs to kind of clear up the console a bit. And back up to the most recent. And I see that we also need to return the result from get customer orders by date, which of course will be this result that we worked also relatively hard to build. So we can return result from this method. After all, what's the point in doing all this work if we're not actually going to return the results? And so R contains this nice data structure now, so we can console.log it out. And let's take a look. So we've got this data object, and it contains an array of objects that have a customer on them with a name, and then an orders array for each of the customers, which is in this nice format where we have a date with this friendly date format and the order total for that day for that particular customer. All right, so that's looking pretty good. So now what we can do is finally push our data into a format that is usable by chart.js. So we have our nice data structure in our constant R here. And so what I'm going to do is set this line chart labels equal to R. And then we'll grab the, doesn't matter which index we grab from R in this case, since they all have the same dates. But we'll look in the orders for the first customer in this case. As I said, it could be any. And we'll map from orders, we'll just map each of the order dates. And we'll reverse them to be sure that we have the earliest date on the left side of the x-axis. And then as for this line chart data, we have an array of objects that chart.js expects. So we'll have 3, one for each customer. And the structure will be as chart.js expects. So we have this data object, which in our case will grab the first customer, then we'll grab the orders from that customer, and we'll map the order total from each of those orders. Chart.js then expects the label, which in this case is just the customer name. So it'll be the first customer, and all we have to do is repeat this for the other 2 customers. So we could write another map function here to map out these custom objects, but just to get it working, just quickly manually write it out here. So let's take a look at the page. Okay, it looks like we may have an error because I don't see the chart. Cannot read property orders of undefined. All right, so let's take a look. R at index 0 of orders, and let's go ahead and console log R back out. So we'll refresh. And R is populated, and our orders appear to be populated. Okay, but okay, I see. We need to be looking in our data object. So R in the data object. So now if we take a look at our page, yes, so we're getting our line chart out, and we need to refresh. And so there we go, it's looking pretty good. I do see one thing here though, that the dates are reversed, and that's because I sorted them previously, so we don't need to reverse them. So we'll do this. And so yeah, now we have dates running left to right in chronological order, and we have data for each of our 3 customers. So that's looking pretty good. A little bit of cleanup we could do here is, rather than looking at the sort of key total, we could just say x dot total as well. Likewise here, we should be able to say dot orders. Okay, so just a little bit of cleanup. And again, we could write a method so that we don't have to manually put in R0, 1, 2, etc. to check out each index explicitly. But I'll leave that for you to do. Certainly there's probably some more optimization that we could do inside this class. It is definitely the most complex component in our application. That's not necessarily a good thing. It's just that we had a lot of data manipulation to do in getting the data back from our API from multiple sources and restructuring it into a way that we could use it nicely with Chart.js. So this was kind of a monster of a component, but I hope you enjoyed building it. In the next video, now that our visualization dashboard is complete, we'll take a look at improving our system health so that we're actually using data from our API to turn these server objects on and off.